So let's talk about SQL injection. Command injection is all essentially the same. You can inject a command even though you are the user, which is interpreted by the server as a command that came from basically some kind of administrator, somebody that writes to execute command. And the first one here, you're executing Linux shell commands, bash, and this one you're executing SQL commands, database commands, structured query language, and the third one you're injecting Microsoft Windows command line commands, Windows command shell. And so the SQL injection is the most important, the most common, and the most unfamiliar to students because most students don't know SQL. So the first thing you have to do is learn how SQL works. And so here, I'll reset the server. I set a script to reset the server, and I see someone on Twitch that says you can't join the Zoom. That's true. This Zoom link is not my normal Zoom link. It's one for this conference, but you can follow on Twitch. And you can put comments there. So you should be fine. So here, down here is a place where you can execute raw SQL commands, like show databases and show tables. And this is something the administrator can do, but you wouldn't normally let a user have the ability to execute commands like this because they're too powerful. You can delete tables, add data, change records, and all that. This is not something a normal user should be able to do, but the administrator controls databases this way. And you see this SQL server has two databases, one called Information Schema and one called Widgets. And so you can see what tables exist with show tables. And you'll see in the widgets there's a table called employees. All right, and so I could see what's in the employees table with select star from employees. That will tell me all the data in the employees table. And there you see I have employee names and social security numbers. So this is information that really shouldn't be public. And all right, so that's why this is something you would only let the administrator do. You wouldn't want a normal user to have access to this kind of control. Now you can do other kinds of select. You can select just a number, like 1, not from a table or anything. And when you do that, it'll just return 1. So that seems pointless, but we're going to have a use for it. You can also select text, like peanut. I did not take my copy and paste. Let's try it again. There. So if I select peanut, it returns peanut. And you can combine two strings. You can concatenate peanut and butter. And then you get peanut butter. And we're going to use these things later. All right, you can also pick a character out of something. Like you can select a substring of the word peanut starting at the letter number 2 and continuing for 2 letters. So if you do that, you will get EA. It starts counting at 1, this is letter 2, and you get a total of 2 letters starting at that point. All right, and you can select a if condition. So this is going to ask me whether the second letter with 1 letter is equal to E. It's going to print the results of that if statement. And the answer is 1 because it's true, because the second letter is in fact E. If I change that and say is the second letter A, that's going to be false, and that's 0. So it's 1 for true and 0 for false. These are just the features we need in the SQL structured query language. So now I've selected all the data from employees. I could also select just one field, like ID. And now I'll get the ID numbers of the various employees. And I could select ID and then 2. You can select a constant. So some of the data comes from a table and some of the data is a constant. I need the S. All right. So now I have ID2, and so on. All right. So now I could get any kind of data if I could execute a select query if I know the name of the field I want and the name of the table. And in order to find the names of fields and tables, You would have to guess them, and that might be difficult, but it turns out to be easier than you think because of this information schema tables. The information schema database is automatically created by the MySQL server, and it has all the information about the tables, and it always has the same name. So you learn how to get data from the information schema tables, and that gives you the data you need to dump the data from the other tables that contain the company information. So this is going to get everything from information schema tables, and this lists all kinds of information about the tables. And none of that is very interesting. It's all automatically generated stuff. What's more interesting is to select table name from information schema tables. This is going to give me a list of all the tables in all the databases on this server. And so these tables are the automatically generated tables with capital letters, and at the end is the table that was created by the local administrator to store company data, and that's called employees, and it's not in capital letters. It could be, but in this case, which is very common, the tables created for the company are made with lowercase letters, and the capitals are automatically generated ones. All right, I see Chuck with the XKCD. Perhaps it's the SQL injection one? And it is, yes, exploits of a mom. Yeah, that's a good one. This is what we're going to do. We'll do an exploit like that one. And in fact, that's why I had to reset the table. So you can inject things like drop table that will execute, that would destroy tables off the server. We're going to do less drastic things than that, but you can do things like that. All right, so now I've found the tables. I can also find the columns. I can do column names from information schema columns. So this was a list of all the tables that exist, and this is going to be a list of all the columns that exist. And once again, there's a whole lot of automatically created columns that the SQL database software creates, and way down at the bottom are the columns created for the company data, which are ID, name, and SSN. So there's an employees table that contains ID, name, and SSN fields. And now, if you want to just get the column names from the table, now that you've found the table name, you could put a where clause in. This will get the column name from the master list of all the columns, where the table name equals employees, so it'll only tell me the columns in that table without all that extra information that I didn't need. And now I get the stuff I want, ID, name, and SSN. So that's how the database administrator uses MySQL to control the database. And here's, by the way, you'll see a whole bunch of records in there for Kevin. This is the command that inserts Kevin, and you see some students have inserted Kevin dozens of times at the end of this table. So now you want to find things. And up here, you can totally find these things. Somebody's social security number, and you can find in one of those long lists is this field. So there's a couple flags to find by just using some of these. But now we get to the interesting stuff. This part is not very interesting. This is just using SQL as intended by the administrator. We haven't really overcome any security barriers yet, but now we're going to do that. This is SQL injection. And where you see that line, this is a different database here than above. So now we have here's what you would get an end user. You would not let them have a field like this where they can execute any select query, or they'll foul up your database. What you do is you let them do something like search for a user. So I can search for Bill Gates, for example, and I submit it, and it finds Bill Gates. I do have a user named Bill Gates. Okay, that's all it does. Now it shows me what the query is. Select name from employees where name equals Bill Gates. And the point is, this was put here by the administrator. The only part of this I control is that. So I cannot execute a select query or anything goofy. All I can do is give it a name, and it will look up the name. The problem is it's vulnerable to command injection, and you can see that if you put in a name with an apostrophe in it, like Tip O'Neill. So I put in that name and submit. Now I get a SQL syntax error. This is the kiss of death. When you see a syntax error, what that means is you have confused the server and created an invalid command. Now, I should not be able to make a command invalid by just putting in a name, but I can because this is parsed as if the administrator had typed it, and it tries to match this apostrophe with a closing apostrophe, and it interprets my apostrophe as the closing apostrophe, so it interprets tip O as the name, and then it expects a SQL command here, and it finds Neil. So I've managed this text over here that came from me is interpreted as a command, not a data to match in the database. And that's a fatal flaw. I have command injection. By inserting punctuation marks, I'm able to inject commands, but I can only inject commands in this language, SQL. So if I put in a poorly formed command, I create an error, but a carefully crafted command will now execute code on the server. And so that'll be here. If I search for Sam, I get no result because there is no customer named Sam in this database, no employee named Sam. It's not an error. That's a perfectly valid query. It just happens to have 0 results. But if I do this, Sam apostrophe or 1 equals 1 pound, now I get all the users on the server. And the reason I do is because this is interpreted as where name equals Sam or 1 equals 1, which is always true, and the pound starts a comment and eats up the last apostrophe. So this is no longer an invalid command, but what it is the condition of when to show me the name is a compound condition, where the first condition, name equals Sam, is never true, and the second condition, 1 equal 1, is always true. So this compound condition is always true, and I get all the data in the database, all the names in a database in this case. So that's one simple form of SQL injection. And here's an even worse one. This, you can do a union. You can add 2 select queries together. So if you do this, it now does 1 select for name equals Sam, then it adds the data from a second select that selects 1. The Sam has 0 answers, and the 1 appears here with 1. So the point of this is I now have the ability to inject a complete select command that's totally under my control. So I can do any of these select queries up here, which were reserved for only the administrator to do. Now I've found a construction where even though I can only put data in for the name, I can in fact execute a complete select command under my control. So now you can find the name of the database, the name of all the tables, the name of all the fields, and you can ask for any data from any of those and see it. The only rule is, though, you only have 1 column. If you try to select 2 things, like 1, 2, then you'll get this error where they have different number of columns. The administrator wrote this part where it selects only 1 field called name, so you can only select 1 column to add to it. So that's why you might need the concat command to combine 2 things together to fit them in 1 column. So now you can pump out some data from the database here. And if you want to, you can use a SQL map command on Linux, which is what the pros do, which just automates this process. And the last part, I think, is probably the most fun, which is blind SQL injection. So here, you got another query. Let's try Bill Gates again. You can search for Bill Gates, and it found a user named Bill Gates. So far, it looks like it's the same as the previous one, but it's not. And the reason is, try X, search for user named X, and you get no result. It didn't find anybody named X, so that's all right. But if I put in one of these injections, X or A equals A, now, this is now select name from employees where name equals X or A equals A. So this should give me all the names, but it didn't give me all the names. It just echoed back my query. The way this one is structured, when you find any results, it echoes back the name that you put in, but it never prints any data from the database. That's why they call it blind SQL injection. I can input data and I can execute SQL commands, but I cannot see the result of those commands. And this is very common on web servers, that you can execute a command, but you can't see the output of your command. You can still hack into the server, and you can still find out what's going on the server, but you have to do it indirectly. And so what you have to do is this. You combine a situation. This one here is X or A equals A. If I change this to B equals A, now I get no results because the first condition is never true and the second condition is false. So I've created a situation where if this second condition is false, I'll get no answer, and if it's true, I will get an answer. I can now play the game 20 questions. I can ask true-false questions and get one answer per query. So here, for example, this one will tell me if the length of the database name equals 1. If that is true, I'll get an answer. If it's false, I will not get an answer. So I submit this. It's false. The length of the database is not equal to 1. I could see if it's greater than 1. And it is greater than 1. So I just say you can express any condition here and you can find out if it's true or false. So by asking a series of questions, you can learn anything you want. So here you get the length of the database, then you want to get the social security number, and for that, you can start with things like this. This is going to select name from employees where name equals Bill Gates and substring. This is the sort of query you do to pump out alphabetic data. Let's try this one. It gets kind of long, but it's not too complicated. If you run this one, you select name where name equals X. This is always going to find nothing, but then I add a second select. This is going to select name where name equals Bill Gates and substring name 1 equals B. So this is going to pick out the name Bill Gates and the first letter is B. So this condition is true, so I get an answer. Now if the second condition was false, I would get no answer. So if I make this into, say, C, now I'll get no answer. So if you figure out how to refer to things like the password, you can find out letters of the password this way. And by the way, you can treat letters like they were numbers. The first letter is B, so that is less than C. And that's true. So you don't have to try all the letters A, B, C. You can try in the middle, greater than or less than M, greater than or less than J, and narrow it down that way. So there are various things to find here in this blind SQL injection. And so that's what I wanted to show you, the SQL injection, which is a good thing to learn how to do. Stop recording.